Good morning, good people. Once again, my name is Hendrik Makaneta, and of course, today's lesson is grade 9 mathematics. We'll just carry on now with our lesson today, just as we did yesterday. So please, once again, let me also indicate to you that it is very important that we participate in this lesson. We can do so by using the group chat. Alternatively, you can raise a hand if you have to ask a question, or just to make a comment, that's fine. And of course, we carry on with common fractions, just as we did yesterday. We will be looking at the equivalent fractions. Yesterday, we did not touch much on the equivalent fractions, so I'm just going to basically take you through the fractions. And of course, you will recall that we define a fraction as a portion of a whole. So a portion of a whole, it's called a fraction. And of course, we have got several examples here of the fractions that have the same value. Yesterday, I also did that, when I showed you how to add and subtract fractions. We had an opportunity to look at the fact that the denominator should always be the same if you are adding or subtracting the fractions. So you need to make sure that your denominators are the same. Now today, I'm just demonstrating to you that equivalent fractions have the same value. So if you look at this example, we have 90 out of 100, and then this 90 out of 100 can be written as 9 over 10. Because 9 over 10 and 90 over 100 are equal. And why are they equal? That's simply because you can multiply 9 over 10 by 10 over 10. So you can multiply the denominator with 10, and whatever you do to the denominator must also be done in the numerator. And 9 times 10 is 90. 10 times 10 is 100. So this is what we mean when we talk about the equivalent fractions. So I'm going to give you an opportunity to reflect on a number of equivalent fractions as the lesson progresses. But for now, I will just look at defining our fractions. And I'm going to start with the proper fraction. So you will recall that any fraction will consist of a numerator and a denominator. Those are what we call common fractions. So common fractions will consist of a numerator and a denominator. So at times, the denominator might be bigger than the numerator, but in other instances, it may be smaller. The denominator may be smaller than the numerator, sorry. So if the denominator is bigger than the numerator, then we say that the fraction is known as the proper fraction. Simply put, if the numerator is smaller than the denominator, the fraction is called a proper fraction. But if the numerator is bigger than the denominator, then we are talking about an improper fraction. So there's a distinction between a proper fraction and an improper fraction. So those are the two different fractions, also known as common fractions. We have an example here, 5 over 7. And of course, These are the examples of proper fractions. So 5/7 is a proper fraction because the numerator is smaller than the denominator. And 2/9 is also called a proper fraction because the numerator is smaller than the denominator. The same note, 32/35, this is also the same. 32/35, that is also a proper fraction, reason being the numerator is bigger than the denominator. And then you can carry on to look at the next ones there, 78/120, and the last one being 12/1000. So they two are the proper fractions. So they are proper because the numerator is smaller than the denominator. In the same note, you can also look at the examples of the improper fractions. You can have the denominator being less or smaller than the numerator. Example, we've got 8/3, 12/7, and then 32/5. And of course, 327/12, 1000/13. Those are the key examples of improper fractions. I'm not going to waste a lot of time. I'm just going to zoom now directly into a mixed number. You know, yesterday we solved the mixed numbers. We simplified the improper fractions, and you know the improper fraction can be written as a mixed number. So for instance, you have 12/7, which you can rewrite as a mixed number, and then you know 7 into 12 goes once, and then into the remainder there is 5, and then over 7. So that is the example of a mixed number. The second one there is 32/5. Once more, you have 5 into 32 goes 6 times. And then, of course, the remainder is 2 because it goes into 30. So the remainder is 2/5. So 6, that's the whole number, and then 2/5. Those are examples there of mixed numbers. We are carrying on with our lesson just to also demonstrate a wide range of examples to simplify. So if you were to just simplify this expression, how would you simplify this? We have got 3/24. If I say to you, just simplify this fraction, how are you going to simplify it? We have 3/24. How do you simplify 3/24? Then, of course, Unkabet just said you can write it as 1/8. Yes, that's correct. Because 3 into 3 goes once, and then into 24, it goes 8 times. So as Unkabet has said, then you've got 1/8. So 3/2 can be written as 1/8, as you can see there. So I fully concur with Unkabetse. Thank you very much indeed, Unkabetse. And then we also have B there, 12/60. Can we rewrite this as a simplified version of the proper fraction? How can we simplify this? 12/60. I need an expression now. So the basic thing that you can do is to divide each element there by 12. In other words, you can divide the numerator by 12 and also divide 60 by 12. So obviously 12 divided by 12 is 1. So the numerator is 1. And Bugs says 1/5, followed by Tando Ngubane, and of course Onkabetsi. Yes, 1/5 will then be our answer there. So 1/5 is the correct answer. Now, can we proceed with the next one there to just this one now? It's an improper fraction. So you can see that it is different in a sense that the numerator is bigger than the denominator. So can we write this one as a mixed number rather? Right, I see Tando says we can write it as 6 and then 2/5. Tando followed by Unkabetzi. Amra as well, welcome back. Amra says 6 and then 2/5. I see Cleo says 8/1. Cleo, I just want you to check your calculations quickly, just to make sure. Kelly says 6 and then 2/5, followed by Unkabetzi there. Right, I agree with you. And King K as well. Thank you so much, King K. Cleo, I hope that you are now looking at the fact that 5 goes into 30, it goes 6 times, and the remainder will be 2. So the basic mixed number there will be whole number 6 and then 2/5 as a fraction. I hope that you can check that. So the rest of you, I fully agree with you. So indeed, as you can see in the board now, we write it as 6 and then 2/5. And that's how we simplify this fraction, but also called the improper fraction. When we go to D, 29/20, again, you will be able to see that this is an improper fraction. And the manner in which you go about it, you'll have to divide by 20. I see Unkabetzi has done it already, followed by Cleo. And then Tando as well. Then Bugs, I see that everyone has the same answer, which is 1 and then 9/20. Yes, I fully agree with you. So it will be 1 and then 9/20. And this simply means you have 20 goes once into 29, and the remainder there is 9. So you've got 1, which is the whole number, and the fraction 9/20. All right. So that is D for us, and then that is 1, and then pardon me there for the 1 there. 1, and then it should be 9/20. And then in E, we just have an improper fraction. Can we just find a way to solve this improper fraction? Right, I see that Unkabetzi and Tando, in fact, let's start with Tando. Tando says you will have a whole number there, 1 and then 3/6, followed by Unkabetzi has got 3/2 there, which is 1.5. Yes, I agree with you, Unkabetzi, that's also correct. 3/2 is also correct, Unkabetzi. And then Amra has got 1 and then 3/6. Okay. And Cleo has got 1.5. So basically, Amra and Cleo, you have the same answer. 1 and then 3/6, 1.5 there. That's correct. Because remember, Amra, if you simplify that 3/6, that fraction, it is the same as half. So 1.5, that's correct. Even Unkabetzi found 3/2. I see now Unkabetzi has simplified the 1 and then 2/3. It should be 1 and then 1/2. Bugs, 1, 3/6. That's correct. So you can see, I also have the answer that was written by Amra there, which is 1 and then remainder. Remember that 6 into 9 goes only once. The remainder is 3/6. That is the remainder. Now, Bugs, you are correct. That is also the correct answer. Can we also look at this 45 over 8? Let's look at 45 over 8. Right, 45 over 8, I just want to know how are we going to solve this. Right, I see that Amahle, right, Amahle says 5 and then 5 over 8. Right? I agree with you, Amahle. And of course, let's see the next one. Yes, Bugs also says 5 and then 5 over 8, followed by Kelly. Kelly as well, whole number 5 and then 5 over 8. Yes, I agree, because 8 goes into 40. It goes 5 times, and then the remainder, if it's 45, then the remainder will definitely be 5 over 8. So this is how we solve this basic common fractions. So please remember these things, especially as we proceed towards our assessments, and then you will be assessed on some of these examples. Let's look at G rather, 240 there over 50. You can see that if you want, you can cancel out the zeros there, and then this is the same as 24 over 5. This is the same as 24 over 5. Remember that 24, 5 cannot go there without a remainder. So Nosipo, as well as Unkabezi, they have got 4 and then 4 over 5. Tando as well, and then Clio as well. So yes, you are right. In my case here, I wrote 4 and then 40 out of 50. So 40 over 5 over 50 is the same as 4 over 5, because those you can cancel out the 0 from the numerator to the 1 in the denominator. So definitely this will be the mixed number. So I just thought today we must also look at the basic tenants there. And let's look at a word problem. Here's a word problem. We have got a few here. And then, of course, I'm just going to ensure that we read this question, which is a word problem. Now, Lindiwe has got marbles, about 40 marbles. Is it 40 there? Let's check thoroughly. No, 14, sorry. Sorry. It's 14 marbles. I just put this group chat was hiding my view there. So it's 14. There are about 14 marbles. And of this, 4 marbles are, let me check, are blue, 7 are red, and 3 are yellow. So what fraction of the marbles are red? Remember, 4 is blue, 7 are red, and 3 yellow. So now we need a fraction. So I can see Unkabet says the fraction is 7 over 14, followed by Tando, 7 over 14, or half. Yes, Cleo also says 7 over 14, or 1 over 2. And Kelly also says 1 over 2. Wonderful. So you simply take the fraction there, the red is 7, and then you know that in total there are 7 red marbles, and the total is 14. So therefore, the fraction is 7 over 14. And then if you simplify that, it can give you just half, or 1 over 2. So those are the fractions. And now we need to have this class activity. I just want us to look at this class activity where Sihle walks every day for 2 3/4 of a kilometer to school, and then he walks another half a kilometer to the grandmother's house. So I just want us to add these two, and let's check how many kilometers. So you are going to use addition of fractions, and then of course we can take it from there. I just want us to add the two fractions together. Remember, 3/4, and then you can just add the half there. I hope that you can see the question. I see that you are battling with the question. Let me read it again. Every day, Sihle walks 2 3/4 of a kilometer to school, and then walk another half a kilometer to her grandmother's house. How far does Sihle walk every day? So it means you just have to add the two. That mixed number there, which is 2 3/4, you add it to 1/2. So if you add them together, what do you get? I see Cleo already has the answer. And Cleo says 3 1/4. Yes, I agree with you. Cleo, and then Nosipo as well, Nosipo Pungula. You have just added the mixed number with the half, and you found 3 and then 1/4, which is 3 1/4. Cleo as well, and then Tandong Gubani, I've seen that. Kelly also found 3 1/4 of kilometers. So it's 3 kilometers plus a quarter of the kilometers, which will be about 250 meters. Right, that is the answer there. And thank you very much indeed. So basically, we are just revising the fractions, but I'm also going to take you to, in this same lesson, just take you to some of the expressions that we probably have done up to so far. And then you'll get more examples as we carry on, just to reflect. So we have now spent almost half of the lesson, or half of our lesson. We've spent it now on fractions. And then, of course, I want us to proceed to do the next half on these fractions. We need to now calculate the fractions. If we have, just recap, and then let's look at the first one there. Remember, this was different in a sense that the denominator is not the same as the numerator. The denominator is not the same as the numerator, so remember that you don't have to add the numerators and the denominators. Some people will say 1 plus 3 is 4, and then 3 plus 5 is 8. I see Nosi Po Pungula has got 14/15, followed by Clio. Yes, 14/15, reason being you simply convert your denominators, you find the LCD, the lowest common denominator. And then once you have the LCD, you can be able to find or add rather the numerators. So the LCD is 15, and then you can see that you multiply the 5 by 3 to get 15. So the numerator there will be 5, and then the other numerator, 3 by 3 is 9. So 5 plus 9 will be your numerators. So 5 plus 9 is 14. Thank you very much indeed. And then the next one, Nosipo has found 7 and then 13/14. Again, all that you need to do is to convert your mixed numbers into into fraction, into common fraction, which is where the denominator is bigger. In fact, it's smaller than the numerator. The so-called improper fraction. If you multiply 5 by 2, you get 10, and then plus 1 is 11. All right, 5 times 2 gives you 10, and then 10 plus 1 is 11. And the other one, 5 times 5 is 40, plus 1 is 41. So you've got 41 over 8, and then 11 over 5. All right, so 40 will be your lowest common denominator. And then finally, you can have 7 13 over 14. This shows that we understand how to find the LCD. Right, and then let's look at the next one. I hope that we are fine. I see that most of you, Tando, got it right. Cleo as well, Unkabetsi also. Nosipo found 37 over 12. I'm sure Nosipo is now talking about the third one. Yes, I can see you reflected that number 3. Is it 3? Oh, it's 3 and then 7 over 12. Tando Gubani also found 37 over 12. And then Cleo has got 1 over 12. I don't know, is it 1 over 12? Or is it 3? Or it's 3, 1 over 12? Yes. 37 over 12 is the same as 3, which is the whole number, and then 1 over 12. I agree. I fully agree. And then Unkabetse has already proceeded to the fourth one. I see that Unkabetse has already proceeded to the fourth one, where she now has 17 over 12. And then, of course, that is an improper fraction. Can you simplify that improper fraction, Unkabetse? Just simplify that as well and give me the mixed number. Right, you have got 1, which is the whole number, and then 5 over 12. Thank you very much indeed, Onkabetse. And then Tando as well, simplified version, and then whole number 1. The fraction is 5 over 12. Thank you, Tando. Who else? Cleo, I've been to you now. I've checked your work. Right, so it's Onkabetse, Nosipo, Tando as well, the latest. And then they were doing the fourth one, right? That is what it means when it comes to fractions. So basically, I want you to know how to add and subtract fractions. I also want you to look at the different ways in which you can simplify your common fractions. And then, of course, tomorrow we'll probably look at the multiplication and division of fractions. So for now, I want to take you back to the flow diagram. We have already finished almost 30 minutes now, but I want us to look at the flow diagrams just to recap, also using the input values to find the output. So remember, in a flow diagram, you are given 3 things. There are 3 things that you need to remember. The first one is the input. The second one is the rule. And the third one is the output. So it's input followed by rule, followed by output. All right. The input, and then the rule, and the output. Those are the 3 things. So in this first one, you can see that we have got the input here. And then, of course, I want us to use the inputs to find the output. So if you can check the first input there, we have 2 in the input value. And then if you take the 2 there, 2 times 2 will give you 4. And then 4 times In fact, 4 plus 8 will give you 12. So can you see this output 12 comes from the first input, which is 2. So 2 multiplied by 2 is 4. And then 4 plus 8 is 12. So I see that Nosipo has already zoomed directly into the second input, which is 4. So I'm looking at your work in the group chat, Nosipo. I see that you multiplied 4 by 2 to get 8. And then 8 plus 8 is 16. Correct. That is correct. I'm glad that you can see the rule. So the rule is in the middle there. And the rule is times 2 plus 8. That is our rule. The output values are on the right-hand side. Excuse me, and then the input values are on the left-hand side. So once again, Nosipo and Onkabetse have zoomed into the second one. Onkabetse and Nosipo, you've got 24 for the next term. So 8 times 2 is 16, and 16 plus 8 is 24. I agree. Onkabetse has got 28 for the next term. So 10 times 2 is 10, is 20, plus 8 is 28. I agree with you, Onkabetse. Nosipo has done the next one. 12 times 2 is 24, and plus 8 is 32. Nosipo Pungula got it right. Also, Onkabetse got it right, where she multiplied 12 by 2 to get 24. So we are done with the first flow diagram. We are done with the first. Can we move into the second? The second flow diagram. 2 times 8 is 16 plus 2 is 18. Yes, Onkabetse has done that. And then 4 times 8, 4 times 8 is 32, and 32 plus 2 is 34. Yes, Onkabetse also got that one right. Kelly also did the first one. 2 times 8 is 16. 16 plus 2 is 18. Yes, Kelly, you are right. Onkabetse has done now the third one, where she found 66. 8 times 8 is 64, and 64 plus 2 is 66. Thank you very much, Onkabetse. I see Onkabetse has also done the next one. 10 times 8 is 80, plus 2 is 82. So Onkabetse got 82 together with Tando Ngubani, there is 92. Kelly got 82, Tando 82. Onkabetse got 98 for the next one. Okay, 12 times 8 is 96. Yes, if you add 2 there, you'll get 98. So Tando, I hope that you correct 92 there, it should be 82. If you are multiplying 10 by 8, is 80, plus 2 is 82. So basically, those are the relationship between the flow diagrams, which consist of the input values as well as the output values. And then we should be able to use this thoroughly when we prepare ourselves. And then the next one, of course, will be the case of just looking at the different algebraic expressions. And then in this case, just the shortest version, if you want to rewrite it, remember that we have multiplied the expressions before. And then we have the first one there, which is x plus 2, open bracket, x plus 3. And then you can see that what we have done here was just to demonstrate that if you have x plus 2, open bracket, x plus 3, the first step is to break the bracket. So thank you, Tando. I'm glad that you've corrected that. The first thing in this case is to break your bracket. And then you can see that x plus 2x plus 6 is what you will have, because 2 times x gives you 2x, and then if you also add the 2 times 3, there is 6. So from there, you just collect the like terms. Remember, the like terms in this case are x and 2x. So if you add them together, you'll be able to get 3x. So it's 3x plus 6. That is our answer there. And then the next one you've got 5 into 4x plus 3, and then close the bracket, plus 5x. Once again, you break the bracket. And then always remember, there are learners who sometimes make the mistake of just multiplying the first term here by 5. 5 times 4x is 20x. And sometimes they forget to also multiply the 3. So you can see that I also multiplied 5 by 3 to get 15. So don't forget to multiply the second term as well. And thereafter, you just collect the like terms. And the like terms in this case will be 20x and 5x. And then you collect the like terms. You can add them together. 20 plus 5 is 25. So you'll have 25x plus 15. So those are the expressions which we are now simplifying. So that's 1.2. And then the third one as well, you can see that we have got even 2 brackets. One has x plus 5 and the other has got 2x plus 1. But in the same note, you just multiply the 2. First things first, if you multiply 5 by x, you get 5x. If you multiply 5 by 5, you get 25. And then if you multiply 3 by 2x, you get 6x. And then the same 3, if you multiply it by 1, you get 3. So 5x, once again, you collect the like terms. And then the like terms in this case are 5x and 6x. And then if you add them together, they will give you 11x. And then 25 plus 3 is 28. You can see the final answer will be 11x plus 28. And then we also have the 5 plus x all squared. And then this becomes 5 plus x into 5 plus x. And we know that 5 times 5 is 25. 5 times x is 5x. And then x times 5 is 5x. X times x is x squared. So once again, you collect the like terms, which is 5x and 5x. Then 25 plus 10x, because 5x plus 5x is 10x, and then you bring down the x squared there. So your solution will be a trinomial there. So it will be a trinomial, which is 25 plus 10x plus x squared. So that is what we do. And then the last one, is there the last one? Yes, there is. You can see the last one there, 1.5. Once again, this is even a bigger expression because of the trinomial in the first instance, and then inside the first bracket there, we have a trinomial. And then the second one is a binomial. So you simply multiply everything, that all the terms of your trinomial, multiply those by -3 to get -3x squared, and then minus 6x minus, remember the -3 times -3 is +9. So this is where the +9 comes from. You multiply negative number by a negative number. And then in the case of the binomial there inside the bracket, again, you multiply that by 3. So 3x squared plus 12x, because 3 times 4 is 12. At this point, you can collect the like terms. So you'll see that in the third step, or the last step just before the last one, the step just before the final answer. I have collected the like terms. I've grouped them together. The first one is negative 3x squared plus 3x. They can cancel out. Remember, negative and positive cancel each other if the terms are equal. And then minus 6x plus 12x. You can just subtract 6x from 12x because it says minus 6x plus 12x. So it's the same as 12x minus 6x. And then you bring down the 9. So the solution will be 6x plus 9. Right. And then this is what we have. Once again, we still have the same expressions, except that now we just have to substitute the values. The value of negative 5. Can you work it out now from where you are? Just to substitute the negative 5 for x and tell me what will be the first value there in 1.1. Just put in where there is x, please put negative 5. Can we do that, please? Let's just substitute. Substitute. I want to test your knowledge there when it comes to finding the numerical value of the expression, just by substituting the value of x, which is negative 4. By the way, these are the same expressions that we just spoke about, right? Tando got negative 9 for 1.1. Kelly also got negative 9. I assume you said negative 5 plus 3, which is negative 2. Nosipo also got negative 9. So negative 2 times 2 is negative 4. And then remember the other x will be negative 5. So yes, fully agree. The answer will be negative 9. Right, I see that Tando has now moved to the second one. Tando got negative 225. Is that what everybody got? Right, thank you. We are left with almost 3 minutes now to end our class. Can we just substitute? I see Tando got negative 225 for the second one. And Nosipo Pungula has got negative 27. Thank you, Nosipo. You've done the third one. And I see that you, in the first instance, negative 5 will cancel out with a positive 5. But 2 times negative 5 is negative 10, plus 1 is negative 9. And if you multiply negative 9 by 3, you get negative 27. Thank you, Nosipo. Tando Ngubani on the fourth one has got 0. Nosipo also 0. Yes, I agree, because 5 minus 5 is 0. So the fourth one, you'll have 0. Last one, quickly. What will be the last one? We are left with almost 2 minutes. The last one, there will be, you just substitute. If you can't find the last one, please use this one that I just did, 6x plus 9. So I know that it will be easier for you if you use 6x plus 9. Once again, I see Nosipo, you have negative 21, followed by Tandong Gubani. Yes, Nosipo Pungula found negative 21, and Tandong Gubani found negative 21 as well. So 6 times 5, that is 30. So you'll have negative 30 there, and then plus 9, it will give you negative 21. So I fully agree with Tando and Nosipo. That is the correct answer there. So you can see that we have just calculated now. We've shown you that it will be, this will be the first one there, negative 9, that's what you got. And then the second one is negative 120, negative 27, and then the last one there was negative 21. So this actually brings us to the end of our lesson, except to say that I can give you homework there. Please simplify these expressions, which will certainly go a long way to help you with revision of algebraic expressions. And then when we meet tomorrow, we'll be able to take it forward. I see that we're left with almost 2 days before the end of the week. I hope you will have enough work to prepare for the assessments next week, and then we will outline the procedure as and when it's required. Once again, feel free to send an email to stemdigitalschool@africateengeeks.co.za. This lesson was brought to you by the STEM Digital School in partnership with the Sasol Foundation. Until we meet again tomorrow, thank you very much indeed.